Whoa, it's Mr. Thompson here with a maths video lesson talking about one of my favorite things to teach in maths, and that is proofs. So proving that something is conclusively true. It's always true. It's true everywhere in math, and it's a pretty cool and unique element of math. Something that sets maths apart from science, philosophy, English, history, all that stuff. We can prove that something is always true. So I think that's pretty cool. So I'm going to talk about what a proof is, just give you a bit of a definition, talk about some key terms here. We'll look at what proofs look like, how to set out a proof, and then we'll do an example of a a geometric proof to start off with. All right, so definition. A proof is a series of statements that have each been justified and which conclusively show that a particular conclusion is true. So it's sort of imagine yourself a lawyer in court and showing, yes, I am proving that this thing is true, that it's always true based on these justifications. So what does that mean? How do we justify these statements that we're making? Well, we're going to justify each statement we make with a previously proven or agreed upon fact, right? We're going to use facts that we already know to prove new things each time, okay? Those things that have been previously proven, or the thing that we prove after we've proved it, we can call that a theorem. Okay, you might recognize that name like with Pythagoras theorem, or also known as Pythagorean theorem, and all kinds of other things. So we're going to use theorems to prove new theorems, right? We might also use some things that aren't necessarily called theorems. They're just things that everybody agrees on, or things that are basically obvious, or that are just assumptions or conventions that everyone works with, okay? Those are often called axioms or postulates, but I guess that wasn't important enough for me to write down. Anyway, this might seem a little bit, strange. So let's look at what this looks like, how to format a proof. There's a few parts that we generally have besides the statements and justifications. We have the given. This is the information that you're starting with, the stuff that you're either told at the beginning or that you sort of work out that from whether you're given a picture or a problem or an explanation of a situation. You can write down your given information. And then you want to write down the thing that you're trying to prove, the conclusion that you are trying to come to through the process that you're about to do. Once you've got your given and your thing that you're proving, you're going to write your statements, and you're going to list them out. You list each statement, and generally we write one after the other, one underneath the other, and list them out. There might only be a couple, or there might be many, 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 depending on how complex a proof, how complex the thing is that you're proving. All right. Then next to each statement, and really what you do is you write one statement and then you write its justification. Each statement has a justification that it aligns with. So what you're doing is you're saying, well, here's the thing that's true based on the information I've given. Here's something else that's true. And imagine somebody saying, well, how do you know? And you say, well, I know because such and such. That's the thing that you write as your justification. You write the thing, well, I know that because it was proven here or it's something that's obvious and we all agree on it, or it's proven by this person at this time or whatever, and I can use that as my justification. Okay, so let's look at an example of a proof. In this example, we're going to start with this given information that we have two straight lines. One we're going to call AB with A and B on either end, and the other line is CD with C and D on each end. And those two lines are going to cross at intersection point P. Okay, so let's draw this. And typically, especially with geometric proofs, you do want to have a diagram or a drawing, or you might call it a construction, where we use a nice straight edge, get everything looking real good. And we label it with all the parts properly. So we've got A and B, and then B and C, right? And of course, they meet at this point O in the middle. Okay, we want to prove that angle AOD equals angle BOC. which are these purple ones that I've highlighted here, the sort of left and right angles. And we want to prove that BOD is equal to AOC. So AOC and BOD, the top and the bottom ones, okay, that I've highlighted there in green. Now you might be thinking, well, I know that those are true because those are equal because they are vertically opposite angles. I've been taught this before, and that's great. The reason that you've been taught that is because of the proof that we're about to do. So this proof shows that, yeah, that thing that you might have learned already, or maybe you just learned it for the first time, that that is always true, no matter how big the angles are. If there's two lines crossing each other, those vertically opposite angles, top and bottom, left and right, or however it is that you format it, they're always going to be equal, those opposite sets of angles. Okay, so now that I've got my given and my statement that I'm gonna, my conclusion that I'm gonna try to come to, I'm gonna write some statements and some justifications, a justification for each of those statements. Actually, though, before we do anything that needs a justification, I'm going to do something that kind of simplifies this a little bit. I'm going to take my angles that have big names with three letters and a symbol, and I'm just going to change them to nice, manageable little letters. So AOC is going to be angle A, AOD is going to be angle B, little b, and then DOB is little c. And because I've written it out like this, I'm actually going to show first that the top and bottom, these two green angles, are congruent. And then once we've done that, it kind of just follows that the left and right, the purple angles, are also congruent because it's the same situation, just in a different orientation. Okay, I'll talk about that again in a minute. Anyway, so far all I've done is just said, hey, I'm going to use simplified letters to talk about these angles. I don't have to justify this because I'm just saying this is what I'm going to do. This is what I'm going to call these things, okay? Now, I can write a statement here that says A plus B, so this angle plus that angle equals 180, and B plus C equals 180. And that might seem fairly obvious that we have a straight line and an angle coming out of two angles that make a straight line that makes 180. But we are going to justify that by saying that those are supplement to 180. Now, I've got my little orange squiggle under this B and the C and the 180 to sort of point out that those two things are equal. B plus C equals 180, which of course they do. But what that means is that anywhere I see, for example, a 180, I can replace that with this expression of B plus C. And of course, I have 180 right over here. I can replace this 180 with that B plus C. I'm using substitution. So I get, when I write that out, I get A plus B equals B plus C. I'm replacing this 180 with that B plus C. And again, I can do that using substitution. That's my justification. Some people might say that's like obvious to the point you don't need to justify it. I think why not be thorough? Write justification in there. It's substitution. That's what you're doing. Now, you might be able to see where we're going here. We've got a b on both sides of this equation. So I can just subtract the b from both sides, and now I can make that equal, that becomes just a equals c. And my justification there, you could write like algebra, simplification or simplifying is probably just the easiest. But we're just doing basic arithmetic, more or less. We're subtracting something from both sides. So we get A equals C. So this top angle equals this bottom angle C, which means that because I've defined those as BOD and AOC, that those two are equal. Got a little stray mark that I'm going to get rid of there. So yeah, because I've shown that A equals C, therefore BOD equals AOC. And similarly, what that process that we did, we could just shift the whole thing around by one angle, in our drawing, and repeat the same process, and that would tell us